Welcome to our review on specific heat capacity. Before we jump into specific heat capacity, we need to understand the difference between two words that are quite often used as interchangeable when they're really not. So the first one is temperature. So when we're talking about the temperature, we're talking about how hot or cold something is. And what it's actually telling us about is the average kinetic energy of the particles. So we'd measure temperature with a thermometer, and it has the units of degrees Celsius or Kelvin. And what we find is that a difference of 1 degree Celsius is the same as a difference of 1 degree Kelvin. The second term is heat. Now heat is actually a form of energy. So because it's energy, we measure it in joules with the symbol of a capital J there, and it's going to depend upon the arrangement of the particles and how fast they're moving. So don't mix up heat and temperature, they are different terms. So when we actually heat an object, then we can see three possible outcomes. Firstly, there's an increase in temperature as the energy stored in the system has been changed. Secondly, it could change in state, so solid to liquid, liquid to gas, etc. And thirdly, we could see a chemical reaction occurring. And you're going to learn more about why that happens in your chemistry course. Now let's come on to look at specific heat capacity itself. So first thing we need to know is the actual definition. So when we're talking about the specific heat capacity, it is the energy needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius. And it has the units of joules per kilogram degree Celsius. And this is actually a very useful value to know because it's going to tell us how resistant a material is to changes in temperature. There are three things that we need to consider that will impact the amount of energy needed to raise the temperature of an object. The first one is the type of material, second is the mass of the material, and the third one is how much we're increasing the temperature by. So one of the experiments that you should have done, because it's a required practical, is looking at specific heat capacity. Now there are two different setups you could have used which are shown in the diagrams here. On the right we've got one that's just using a beaker with some water in there, and on the left we've got a solid block, which are usually the metal blocks. Now they both work in pretty much the same way. So you can see that they both have an immersion heater, so an electric heater placed into it. They've both got a thermometer there, and they've also got insulation around the outside. So what we actually do is we connect our heater into our power supply, and then what we're going to do is record how much the temperature changes over a given time, and from our circuit we'll also take readings of the current and the potential difference, which we can then go on to use in our calculations. So as you probably guessed, there is a calculation for specific heat capacity, but there is a bit of good news finally. AQA have decided to stop being mean and actually give you one on the physics formula sheet you get in the exam. So this one, you don't have to learn it, you just need to remember it's on your formula sheet and use it. So the change in thermal energy in joules is the mass in kilograms times the specific heat capacity times the change in temperature. To give you an example of the kind of question they could ask us to do with specific heat capacity, here's an example. So calculate the energy you need to transfer to raise the temperature of a 500 gram block of aluminium by 10 degrees Celsius. The specific heat capacity of aluminium is 913 joules per kilogram degree Celsius. As always, when it comes to a calculation question, the first thing we do is underline, circle or highlight the key bits of information. So I've done that for you in red, as you can see in the question. Second thing to do is to write down the actual formula from the formula sheet. So just copy it into the answer space. Next thing to do is have a look and see what you need to do in terms of working out the mass in kilograms or the change in temperature, because different questions will need you to do different things here. So in this question, we can see that we've been given the mass in grams, so we've got to convert that to kilograms by dividing by 1,000, and the change in temperature we've just been given in this instance. Sometimes they'll give you the start and finishing temperature and you'll have to work out the change. So just look out for those, work them out and jot them down. Last thing we need to do is substitute in those values and then type it into your calculator to get the answer, because remember, all your science exams you're allowed a calculator. So our calculation is 0.5 times 913 times 10, which gives us an answer of 4,565 joules. So when we actually come to think about the importance of knowing specific heat capacity, then we can consider why it's important in things like water. Now, water itself has a high specific heat capacity of 4,200 joules per kilogram degree Celsius. And that's the same substance we use in our central heating systems at home. And the reason we use water there is because it can actually store large amounts of energy because of the high specific heat capacity. And that will then transfer to our surroundings and heat up our rooms nicely. Another kind of heater you may have is a storage heater, and inside the storage heater we've basically got a giant concrete block, so that when the actual electricity is flowing through the heater, it heats up the concrete block, and that's got a high specific heat capacity, so it stores lots of energy again, and it will then transfer the heat to the surroundings at a later time and keep the room warm for a nice long time. Hopefully at the end of this video you can now state what specific heat capacity is and the units it's measured in, and you can use the formula to calculate various items to do with specific heat capacity.